This is a worked solution to AQA GCSE Physics P3, June 2014, question 7. Question 7 is about total internal reflection. In questions like this, where a fibre optic cable is used, in medical physics, quite often in endoscopy, if the incident angle is greater than the critical angle, then the ray is totally internally reflected and all of the beam stays inside the light. So, drawing our normals on here, it's always striking at an angle greater than the critical angle, and so the beam stays in there. So the answer to this 7 part A is total internal reflection. For 7b, it tells us the refractive index of the fibre, and it asks us to calculate the critical angle, which is given the symbol C. The formula we are going to use is that the refractive index is equal to 1 over the sine of the critical angle. So we know that 1.5 equals 1 over sine of the critical angle. That gives us, if we rearrange, multiply each side by sine and divide each side by 1.5, we get that sine of the critical angle is equal to 1 over 1.5, which when we do that in our calculators is 0.66, recurring, something around 0.6667. And in order to then calculate what C is equal to inverse sine, which is just a function on your calculator, of 0.6667. And that gives us C being equal to 41.8 degrees. Part 7c asks us to analyse a graph which compares the percentage of light transmitted against wavelength of the light transmitted for two different fibres, a shorter fibre and a longer fibre. It's clear from looking at the graph that the shorter fibre transmits more light at all wavelengths. So for the shorter fibre, I can say more light transmitted at all wavelengths. It's also clear from looking at the graph that as wavelength increases, the percentage of light transmitted initially decreases and then increases again. And the minimum amount of light transmitted for both the short and the long fibre is at 5 times 10 to the minus 7 metres. So I can make that point that as wavelength increases, percentage transmitted increases, then decreases, minimum transmission occurs at 5 times 10 to the minus 7 metres. The final point I can make is that the maximum transmission occurs for both of these fibres at this value here, 6.5 times 10 to the minus 7 metres. So I've got now at least 3 or 4 things to say about this graph, which should allow me to write a coherent answer to the question. So my first point was that the shorter fibre transmits a greater proportion of light at all wavelengths. For both fibres, as wavelength increased, the proportion of light transmitted decreased and then increased. The minimum transmission occurred at 5 times 10 to the minus 7 metres, and the maximum at 6.5 times 10 to the minus 7 metres. It is essential when answering these questions to include as much detail as possible from the graph, so including these values here should guarantee that we get full marks.